We're building a file system simulator, inodes, blocks, directories, and a shell. No OS calls, just byte arrays. You'll see how files are stored, how directories link names to inodes, and how a file system stays consistent. This is the engine under every operating system storage layer, coded entirely in Java. We simulate a disk with 256 blocks of 64 bytes each. A free map tracks which blocks are in use. Allocate block finds a free block, marks it used, and returns its number. Read block/write block copy byte arrays in and out. This is our persistent storage, all in memory. An inode holds file metadata, type, free, file, or directory, size in bytes, up to 8 direct block pointers, and a reference count. Directories are also files, just storing a list of entries. The inode table holds all file metadata, and we allocate inode numbers just like a real file system. A dir entry pairs a name with an inode number. The constructor creates the disk, an inode table of 64 entries, and the root directory. It allocates inode 0 for root, marks it as a directory, and writes an empty directory list into it. This sets up the initial file system state. We serialize directory entries into a byte array using a simple format, a 1-byte name length, the name bytes, and a 4-byte inode number. Load directory deserializes them, save directory packs and writes them via write file data. This is how directories are stored inside a file. Read file data iterates the inode's direct blocks, copies bytes into a contiguous buffer, and returns the whole file. Write file data frees old blocks, allocates new ones, and spreads the data across them. This is the core of file I/O, mapping a linear byte stream to fixed-size disk blocks. Resolve path walks a path string by splitting on /, starting from root or current directory. For each component, it looks up the name in the directory entries and moves to that inode. It returns the final inode number or -1. GetParent and getBaseName extract the parent directory and final component. These commands implement basic file operations. mkdir and touch create directory entries and inodes. Write stores the given content to the file's data blocks, and read retrieves it. Each verifies types and handles errors gracefully, just like a real file system would. ls lists directory contents, showing names and whether they are directories or files. cd changes the current working directory by updating current rinode. rm deletes a regular file, removes its directory entry and frees the inode. pwd outputs the current path, a simplified implementation. All commands work directly on the inode structure. A simple REPL reads commands from the terminal, mkdir, touch, write, and exit. It splits the input line and dispatches to the corresponding method. This lets you interact with the file system like a mini shell, creating and modifying files and directories on the fly. Compile with javac and run. You'll see the shell prompt. You can create directories, create files, write text into them, read them back, list directory contents, and delete them, all backed by a real inode and block architecture you built yourself. You've built a working file system from scratch, inodes, block allocation, directory serialization, and a shell. This demystifies how operating systems store and retrieve files. From here you can add indirect blocks, permissions, or a journal.